kids, this is how we're going to do the next couple lessons for the next few days. What I've done is I've taped the lessons for the next 3 skills. So what's going to happen is we're going to come to the computer lab, we're going to watch these lessons individually, kind of go at your own pace. You're going to fill out notes like we normally do with class, but it'll be from the Mimeo here. So go ahead and feel free to pause when you need to catch up. Please do everything I ask, like work through the examples, pause when I ask to pause. Okay, the more you follow along, the more the benefit it will be to yourself. So the first skill we're going to do is skill 2.7, perfect squares and simplifying radicals. The first thing we're going to talk about is called perfect square. And a perfect square is the product of a number multiplied by itself. So go ahead and make this 3-column chart with your number, the work, and PS, which stands for perfect square. There'll be a lot of times I say PS throughout this video, and when I say PS, it references to perfect square. Okay? So what I've done is I've done the numbers 1, 2, and 3. Okay? Well, according to what a perfect square is, it is the product of a number multiplied by itself. Okay? So my number's 1, I multiplied by itself. Its perfect square is 1. 1 is the perfect square. 2 has the perfect square of 4. 2 times 2 is 4. 3 is the perfect square of 9. So what I want you to do is I want you to pause the video from this point, complete your table all the way down to 25. Okay, this is a nice reference chart to have, especially when we start simplifying radicals. So go ahead and do that right now. All right, you just got done pausing, you completed your table. We're going to move on to our next topic. Okay? It's called the square root. Okay? The square root is the process of undoing a square. Okay? Or it's the undoing operation of a square. Okay? So for example, we have 9 squared. Well, 9 squared means 9 times 9, which is 81, which you should have just completed in your chart. Well, the undoing operation of a square is called a square root. Okay? Looks like a division symbol, but it's got this little tail at the end. And we got 2, because that means square root. Well, the square root of 81 is equal to 9. Okay? Well, square root can also just look like the flag and division sign. Okay? We don't have to have the 2. So what this problem is, what's the square root of 196? The square root of 96. Well, if you go back to your table, you're trying to determine, is this guy right here a perfect square? Well, if you went back to your table, you figured out, oh yeah, 196 is my perfect square column. What number does it belong to? It belongs to the number 14. Okay? So, now it's your turn. Okay? I want you to find the radical, or the square root of 361. So first determine if it's a perfect square, figure out what number it belongs to. So go ahead and pause and do that. Okay, so now hopefully you've done this, you've gone back to 361, you notice, oh, this is a perfect square, it belongs to the number 19. Okay? So again, all about simplifying is, where does the perfect square exist in this radical? Well, 361 is a perfect square, so I know that its square root is 19. Okay? Moving on. The next thing we're going to talk about is called the product of radicals property. Okay? And what that states is, you take the radical of a multiplication problem. Okay? So if we were to continue this, get my blue here. If we were to continue this, well, what's the multiplication problem inside this radical? Well, it is A times B. Okay, so the radical of a multiplication problem is equal to the multiplication problem of a radical. So, of 2 radicals, excuse me. The square root of A times the square root of B. So the main thing I want you to get from this property is that you can take a number, break it down, and then separate it into 2 different radicals. Okay? So, for example, let's do this guy down right here. The radical of 12. Well, there's a couple things we can break radical 12 down into. 2 and 6, 3 and 4. So let's just go ahead and do 2 and 6. Okay, so radical 12 is equal to 2 times 6, and that's equal to the radical of 2 times the radical of 6. All right? So, there you go. So we're going to use this process to help simplify these radicals. Okay? So, moving on. So when we're simplifying, what if the number isn't a perfect square? Well, we're going to simplify this. Well, we know it's 48. Go back to our T-chart. It's not a perfect square. So our thought process is there a perfect square that goes into 48? Okay? Is there a factor of 48 that is a perfect square? No. A factor is a number that divides 48 evenly. Well, what I would do is I would go back to my perfect square table. I would start with the largest perfect square that could go into 48. So in this case, the largest perfect square would be 36. All right? Well, 36 can go into 48 evenly? No. If I move down, it would be 25. Can 25 go in evenly? No. I have to go to 16. Can 16 go in evenly? Yes. The square root of 48 is equal to the square root of 16 times 3. Well, according to the product of radicals property, we can break this down into two radicals. A multiplication problem with two radicals. Square root of 16 times the square root of 3. Well, from here, can I simplify each one of these radicals? Well, I can't simplify this guy because it's not a perfect square and no perfect squares go into it. But 16 is a perfect square. So the square root of 16, is equal to 4. Okay? So, since I can't simplify this, my final solution is 4 times the square root of 3. Okay? So again, the process we went through. Is this a perfect square? It's not. We want to break it down so that we have a factor of 48 that is a perfect square. Well, in this case it was 16. We can take the square root of 16 to get 4. Okay? So, now it's your turn. Okay? I want you to try these two examples, the square root of 90 and the square root of 84. So go ahead and pause it. If you have to, go back, rewind, make sure you have the process down, and finish these. Okay? When you're done, we'll go through the answers. Okay, so you just finished the problems. So let's talk about square root of 90. Well, is 90 a perfect square? It isn't. So I want to find a perfect square that's hiding inside 90. Again, I suggest start with the largest. Okay? Because when you start with the largest and you find the largest, you're going to guarantee yourself simplest form every time. So 81 does not go into 90. Next in line is 64. Well, it doesn't go into 90. Next in line is 49. It doesn't go into 90. 36? No. 25? No. 16? No. 4? Oh, excuse me. 9? Yes. This can be written as 9 times 10 underneath that radical. Well, again, the product property of radicals says break it into two radicals. Well, can I take the square root of 9? You bet. That is 3. Can I take the square root of 10? Well, 9 doesn't go into 10. 4 doesn't go into 10. 1 does go into 10, but that doesn't help our situation. So our answer here is the square root, 3 times the square root of 10. And lastly, 84. Well, the largest square root that goes into 84 is 4 times 21. Breaks down into the square root of 4 times the square root of 21. We can take the square root of 4, which is 2, times the square root of 21. So that is it for skill 2.7. Once you have finished these, please go ahead, let me know, and I'll give you the worksheet. Thank you.